In our last video, we looked at how to find the volume when we rotate a function about the x-axis. In this video, we're going to continue on from that, but this time we're going to look at how to find the volume when we rotate the same function about the y-axis. For our example, we're going to be finding the volume of the solid generated when the area between the curve y is equal to the square root of x, the y-axis, and the line y is equal to 2 is rotated about the y-axis. This area is given by the yellow shaded region in the diagram. If we rotate this region about the y-axis, then we're going to be able to generate a solid that looks like this. In order to find the volume of this solid, we can think of it as being made out of a series of very, very thin cylindrical discs. And if we're able to find the volume of each cylindrical disc going from y is equal to 0 to y is equal to 2 and add them up, then we would have the volume of the solid of revolution. Now recall that the volume of a cylinder is given by the formula V is equal to pi times r squared times h. Pi r squared is equal to the area of the circular cross-section, and h is equal to the height of the cylinder. We're going to apply this formula to finding the volume of each cylindrical disc. So the volume of each cylindrical disc, which we call delta V, is going to be given by pi times x squared times delta y. Pi times x squared is the area of the circular cross-section of the cylinder. And notice here that the variable r gets replaced by the variable x because the radius of each cylindrical disc is given by the x coordinate corresponding to the y value of the function at each point on the curve. H gets replaced by delta y because delta y is essentially that very, very small increment along the y-axis which represents the height of each cylindrical disc. So if we now want to find the volume of the whole solid, what we then do is we sum up all these delta v's from y is equal to 0 to 2. Now the expression delta v gets replaced by pi times x squared times delta y. And what we do is we take the limit as delta y approaches 0. And all of this then gets replaced by the integral so that the volume of the solid simplifies to pi times the integral from 0 to 2 of x squared times dy. But because we're going to integrate with respect to y, what we then need to do is we need to express the function y is equal to square root of x in terms of y. So now we've got y is equal to the square root of x, so that we've got y squared is equal to x, so that y to the 4 is equal to x squared. So we're going to replace x squared with y to the 4, so that our final expression for the volume of the solid is V is equal to pi times the integral from 0 to 2, y to the 4 dy. Now that we have got the expression for the volume of the solid, our last step is to simply complete the integration. So we're going to integrate pi times the integral from 0 to 2 of y to the 4 dy. So this is going to become pi times y to the 5 over 5 going from 0 to 2. We can take out the 5, so we just get pi over 5 times y to the 5 going from 0 to 2. And we sub in the limits. This will then give us pi over 5 times 2 to the 5 minus 0 to the 5, which evaluates to 32 pi divided by 5 units cubed. And this is our final answer. Thanks everyone for watching the video. If you would like more examples on this topic, please check out our playlist. We also have other videos on other maths topics on our channel as well. And please help us by subscribing. We very, very, very much appreciate your support. We'll see you all in the next video. Bye for now.